Okay, so instead of doing cross-site request forgery right away, let me add one more thing to the cross-site scripting discussion. So, as Conrad had mentioned, using a insert injection to insert via SQL injection, insert a cross-site script into the database and just let it lie there. Wait for a user to come along to a page that selects that record back out of the database and displays it in the user's browser, and then the cross-site script would execute and hook the browser. So if you go over to the register page, let me log out here. You'll notice that you can cause an SQL error to occur. And just like all the pages, they're all programmed to do this exact same thing where they give you the entire query to help you craft the injection. And so you'll notice that here is the entire query. Let's go open a notepad. So you'll notice all this is all very repetitive, or it's going to do the same thing we've been doing all day. It's just an insert query instead of a select query. It's the only difference. So this is where our injection is going to land. And here's everything that's going to be automatically prepended to our query. And here's everything that's automatically going to be postpended to our query, or appended. And so this is the area that we control. That's where our injection is going to land. That's our real estate to work with. So if we were to create a payload, or at least a prefix, this first value right here is what? The very first value. Look at the query, you can figure it out. It's the username. See, username appears first. Password, my signature. Okay. So if we did like backdoor 2, close that off, comma, password, comma, signature, close this bracket right here, and then we need to comment out the rest of this stuff to get it to work, right? And we need that space. We need that space at the end. So if we injected this as an SQL injection, we should be able to control the insert process instead of letting the database, or letting the application decide what to put into the database. We can control what we put into the database. Now this example is a little trivial because the site's so ridiculously vulnerable that you could pretty well just type the cross-site script right into the signature field on the site, and it'd probably just insert it for you if you were careful about it. So you would need to be a little bit careful because remember, special characters overlap. So special characters in JavaScript overlap with special characters in MySQL sometimes, and you do have to take that into account. And remember what layers you're passing through so that everything gets interpreted correctly. But let's say we did, you know, an alert 0 or whatever. So this has a decent chance of working. I'm not positive it'll work, but we can give it a try. If not, I got an example that will work. So we're going to need to go to the decoder. And go back over to the page. Put in a canary or something that we can just get into Burp Suite with. And see if this syntax is good enough. Okay, so the account's been created. And we could have made this username anything. So we could have made, we probably could even use an existing username and send in a second record that is appended if there's not good referential integrity on the database, we might be able to essentially overwrite an existing user's signature so that when they log in, they would get the hook. Oops, let's see, I need to go to the login page. Still on the register page. Okay, let's turn the intercept off. And let's log in as that user to simulate what would happen. So we log in, and in this case, alert box, silly, but it shows that the script that we injected via SQL injection is executing when that code is fetched out of the database by the user that logs in under that login name. The reason is because their signature is displayed up here in the banner right here. So that JavaScript is getting incorporated into the source code that's supposed to be there, plus the little extra snippet that we're adding in when the user visits the page, and it's executing at that time. If instead of having an alert pop-up box, we injected into the database the hook.js back to our machine, if we copied it off of the Beef frameworks server window that was running in and copy that and use that as the injection instead, then each time someone visited the page under that username, it would keep hooking the user repeatedly as long as they were at least browsing in that site.
So obviously if you got an elevated account user or somebody, I'm not thinking an admin or an executive or somebody like that, you're going to put it in general ledger information or critical data, you could be sniffing that data out.
Yeah, if it's an executive, there's almost nothing they do that isn't sensitive. I mean, they're always browsing to, to do some emailing or to look at documents that are stored on SharePoint or the internal document storehouses of the company. So, yeah, the executive browser can get out of hand pretty quickly if you drop a hook into that. So just a quick segue into, I thought of that when he mentioned it, that, hey, we have a demo for that, so why not show it? I've done what I can to get as much information into the hints as possible, but there is a file in Matilda. Actually, I'll just show you here. So if you look in the documentation directory, there's a text file, Matilda test scripts.txt. So whenever I'm working on the pages and I'm testing them out, you always have to kind of come up with some way of testing the page before you send the code up SourceForge. And so when I get a good test and it works out well and it executes properly and does something halfway decent, I'll just throw it in this text file and just kind of leave them in here, and then over time I can come back to the text file and use them to retest the site to make sure it hasn't regressed or anything like that. And I kind of got them broken out in these little titles. So if you would like to use those, you're more than welcome to. They're already written. But keep in mind, they're not necessarily ready to run. You can't just inject that, for example. Don't forget to encode it first and all that. I also wanted to mention that kind of want to try to balance out giving some really good details today with some things to keep in mind at a high level. So the user is not going to cross-site script themselves. You would go ahead and pre-encode the payload, and then you would embed that into a URL, and then you would somehow get that to the user so that they could click on that link that has your payload already embedded in the hyperlink, and then that way when they visit the page, they're passing the cross-site script in as they browse to the page. Does that make sense? So I think we all, as security people, we all understand that clicking on stuff is generally how it works, but that's how that works. Is the payload is already in the link. It's getting sent when they browse to the site and then reflected back to them. That's how the reflected works. Now on the stored, like the SQL injection we just did, we're just leaving a bomb on the site, right, and just waiting for someone to come along. And those are generally referred to as drive-bys because the user doesn't need to do anything except for just visit the page. And the hook.js will execute upon visiting. They don't need to click on anything, they don't need to hover over anything or mouse over, it's just going to execute right away.
Yeah, sometimes I see it also we put this like stored versus reflected.
Right, that's the stored versus the reflected. And it's broken down in the menu under cross-site scripting. Reflected is first, and then the persistent is the stored. It's another name for the stored. So then there's a third type, which is the DOM injection, which is a little more complicated, but it's using the HTML5 techniques. If you'd like to try that one. Okay, now really we'll do cross-site request forgery. Cross-site request forgery is A5, and we're just going to use the add to your blog page, but the registered user and the poll question also make good targets. Oh, let me reset the database. Kind of hack this thing up a bit. So in addition to setting, I think I passed it back in. Oh, you know what? I think it's because I'm logged in as that person. So even resetting doesn't fix it.
Those are the best kind.
Yeah. So persistent and survives a database update.
Is it in your cookie or something? I haven't.
Yeah, it's the signature. I'm trying to remember how that works. It's kind of like when you. I'd have to look at the code, but it's like when you're already logged in as that person, it keeps refetching that back out. I think is maybe why it keeps doing that, including it in the URL, so that when you get redirected back, I think it keeps like serving it up to you. But I'd have to look and see why it's doing that. Because when you go reset the database page tries to be nice and send you back to the page that you came from. But if you have a payload in the like the referrer field, and it keeps trying to send you back to that payload, that URL with the payload in it, it's just going to keep like reinfecting you. So sometimes you might log out and then reset the database. But reset database will literally drop the entire NOWASP database and recreate it from scratch, repopulate the tables with the data, target data, and put everything back the way it was.
What if you get some errors on that? Reset the DB.
Probably have to resolve them. It's not going to work.
That's a great answer.
Yeah. So it would depend on what the error was.
Yeah.
But there's no, I don't think there's any way around it. You have to resolve the errors, or the system probably is not going to have all the functionality. What kind of system are you running?
Linux. It's a LAMP stack.
LAMP stack. Okay. Probably the top things to check would be if the port is the 3306 that Matilda expects, and then also that the username and password are root and blank. And if they're not, then you can go to the mysqlhandler.php file and put in the password that you would like it to use to get to your MySQL server. That's probably the most common issues.
Okay. Thanks.
Sure. So Matilda by default will just assume that the username to the database is root and the password is blank, and that's not always true. Now there is code in there to detect if it'll try to detect if it's running on Samurai, and if it figures that out, it'll automatically change the password from blank to Samurai because that's the password to the MySQL database on Samurai. But those are the only two systems where it can self-adjust, Windows and Samurai. If it's another type of Linux, it doesn't have any code to like try a third password. Okay, so the way the add to your blog page works is pretty straightforward. The user would type in something. They would hit submit. Some hidden fields are going to get submitted. So the parameters we have are the page variable, which is always there. That's the page we're looking at. Then there's those cookies that we saw earlier. Then we have a CSRF token getting sent, but in security label 0, that token is constant. It never changes. Now, of course, in security level 5, it's a really big random number that always changes. In the blog entry variable is the text that's going to be submitted for the blog entry, and then there's the actual button itself. So if we forward this onto the server, it should add that hello world blog entry, and we should be able to see it. So what if you wanted to be able to force someone else's browser to add a blog entry remotely, for example? And one way to do it would be to use beefhook, and then you could just control their browser, of course. But what if you could just leave a little JavaScript on a popular site that might be vulnerable to hosting this kind of stuff, like some popular social networking sites were, or somewhere else where the user might stumble across it in a drive-by. We just talked about drive-bys a second ago. And when that script executes, what if that script told the user's browser to go do something, to go add a blog in? Or the sample you always see in the textbooks is transfer funds out of an account or whatever. So if that JavaScript was able to cause the user's browser to recreate a real blog posting, then it should work. Yes?
One example of that was like the Sammy worm on MySpace many years ago, where he programmed it to where he instantly got added to the friends list of anybody who visited the page, and then anybody who visited their pages also got it and added Sammy as a friend, and so on and so forth.
Yep, that's a really good example. It's a piece of JavaScript that told the user's browser to essentially click the add as a friend button. But the JavaScript was clicking the button. The user wasn't clicking the button. It was a forced browse. So the first thing we need to do to be able to create a cross-site request forgery attack, besides locate a vulnerable page, is we need to figure out how should the page work, because we need to recreate that. Now, to figure out if the page is vulnerable or not, visit the page at least twice in a row, if not more times in a row, and make a note of the differences between the page on subsequent visits. So just, for example, go to the page and submit the form, and then be very careful to go back to the page in exactly the same way and submit the form again. And both times, when you get the response back from the server, so we're going to forward this, and when we get the response back from the server, right-click, for example, and send it over to the comparer. So there's the first response back from the server. Forward that on. And then let's do it again. We typed in the word submit. Let's try to do this exactly the same as best we can. Forward this request on, get this response back, send this response to the compare tool. So now we have two things to compare, and we'll just compare them on the words. And then we'll sync the views so that as we scroll, it scrolls both sides at the same exact time. And then look at the differences between the pages. Scroll down to the bottom and work our way up. So there's not a lot of difference, except for on the second go around, we have the blog entry that we added on the first go around. Does that make sense? Now, if the page had a proper cross-site request forgery token, those two wouldn't be the same because they would be different by at least that token that's embedded in the page. And the way the cross-site request forgery tokens work is think of them as a signature. So as the server is creating this form that it's going to offer to the user, it doesn't know if the user is actually going to use the form or not, but just in case the user decides that they want to fill out the form and submit, the server will sign the form with, say, a 32-byte random string. And it embeds that in a hidden field or whatever on the page. If the user happens to fill out the form and submit it, that random string is going to be submitted as well. The server can check to see if the string on file matches the string submitted. And if the user is the same and the page is the same and the string is the same as what's registered on the server side, if all that matches up, then the server can be relatively confident that the user really did fill out that form. There wasn't a rogue JavaScript that filled out the form for them on their behalf and then submitted the page. Because if a random JavaScript recreated a proper submission, but it wouldn't actually know what the random token was. So when it could try to make one up, I suppose, or it probably more likely wouldn't submit one at all, and the server would be able to detect that it's fraudulent. So we're going to try to recreate this valid request so that we can create the cross-site request forgery. So let's do it one more time. We'll submit it, capture the request, and here's the request. Now to recreate this request pretty precisely in JavaScript, we would need to submit these values, and we also need to be careful to post to this exact URL. But that's essentially all the information that's needed, right? So if we were to just hammer out some JavaScript, we might do something like the URL is equal to there's the server right here in the host header. Then we would copy the file path from the post and add that on. So we've already got the URL recreated. And then we have these parameters that we need to recreate carefully as well. So we can start to break those apart. We break them apart on the and symbols. Those are the delimiters. So if these three parameters are the ones that get sent on a valid posting to add a new blog entry, we need to be careful to send all of them. Even if we don't really think that CSRF token is important, even if we don't really think that the add to your blog submit button is important, you need to make sure that when you're creating the exploit that you just go ahead and just send it all. And then you can alter the part that you want to change, which is, of course, the blog entry is the text that's typed into the box. That's what we're actually trying to force the user to submit in as a new blog. So we would change that to whatever we wanted. Okay, now that we have this information, we can start to write a JavaScript that would recreate the submission, but the user won't even need to click on anything. It'll just fire off in the background and perfectly simulate that request. There's a couple different ways to do this. You can use HTML injection to literally inject a cross-site script, a form that looks just like the form that's on the page, and then get a reference to the form with getElementById and do form.submit. So that'll click the button on your hidden form. You can also generate a new form in JavaScript. So like var my form is equal to document.create element form. So now we have a form, and then we can start to create some inputs. We have 3 of those. There we go. See where this is going, right? So we're building this, we're building a duplicate form in the background. And then we could set input 1.value is equal to security is disabled. And input 1.name is equal to CSRF token. And input 1.type is equal to text. Whoa, mouse got away from me there. Okay, so there's input 1. Oh, and let's see, is it add child node?
Jeremy, after security is disabled, do you need a semicolon or a
Oh, yes. Yep, thanks. I think it's add child node. I probably have to look that one up.
pen child?
Is it add child?
A pen child?
A pen child. Oh, thank you. It's hard not having Google. Okay. Okay. So then we would copy this one and create input 2, and then we would copy that one and create input 3 and fill in the values appropriately. And then we would copy this one and append all 3 input elements to the form element. And then don't forget to document.append child the my form. So you want to append that to the body element.
Document.body.
Oh, thanks. Yeah, left out body. And then you would form.submit. Okay. So kind of walk through the process, at least at a quasi high level, and basically we've talked about how to take apart a valid request, use that template to create your own JavaScript that emulates what that request would have looked like had the user really clicked on the button in their browser. But of course, we're simply going to cross-site script the user so that their browser quietly performs the exact same request, but without them having to take any kind of action. Now, the page that we poison certainly doesn't need, or probably wouldn't be, the page that we're targeting. So there's the idea of the page that we put the payload on, but it's actually going to go affect the target page, and they're not going to necessarily be the same page. As a matter of fact, they don't need to be in the same site. Often they're not. A lot of times this...
Users would need to have a session on the other page.
Right, the only requirement is that the user be logged into the target site. But they don't need to be looking at the target site, they just need to be logged in. So if someone goes to, say, Gmail and looks at their Gmail and then leaves Gmail and goes off to Facebook, actually that probably happens millions of times a day, then when they're looking at Facebook and they're not looking at Gmail anymore at all, the Gmail's gone, they're looking at Facebook now, and that's the only page they're looking at, are they still logged into Gmail? Yep.
Until they log down.
Unless they logged out, or unless they closed all their browsers and do not have Keep Me Logged In turned on, right? So, assuming they're using non-persistent sessions, meaning that when you close the browser, the session goes away. But a lot of people actually do click that Keep Me Logged In button on a lot of stuff. And so they're always logged in. Now, Gmail does have a cross-site request forgery token to protect against that. So I think a few years ago, if I'm not mistaken, maybe like 5 or 6 years ago, they didn't. And I think you could at one time have cross-site request forgery on email. So we kind of have the basics of how this works. And so we don't torture you all having to type all that JavaScript out and get it running exactly perfect. If you go over and toggle the hints, and toggle the hints on the target page, not the page that we're going to drop the JavaScript on to actually pull off the attack, and go down to cross-site request forgery, I think towards the bottom, well, maybe not towards the bottom. Okay, under the examples section, there's already a form-based and HTML injection-based attack to add a blog without consent. And then here is the JavaScript version of that. So in one case, it's kind of a traditional cross-site script that's literally injecting a Java script. And then in the other one, it's a HTML form that you're injecting. So looking at this source code here, what event causes the cross-site request forgery to take place? What does the user do that triggers it? What is it? They hover the mouse over this well, it's an italics tag. So this text here will be italicized, and if they hover over that or pass the mouse over top, even if the mouse is off, it's going to trigger this submission to the add to your blog